Hello, everyone, and welcome to this new discussion where what we are going to talk about here is basically a paper by, let me just increase a bit the size, and that's a paper from 2002, which is about one of the many formulations of quantum mechanics. And this paper in particular is about the infamous many-world interpretation of quantum mechanics. Now, the author of this particular paper is David Wallace. So he's the theoretical physicist slash philosopher or philosopher slash theoretical physicist. And in particular, he has been a very great defender of the view on the many world interpretation of quantum mechanics that people call the Everett interpretation or formulation of quantum mechanics. Now, many people would basically start um, right off the bat by being, let's say, very dismissive of the many world interpretation. So, what it says is that essentially, if you follow what the equations of quantum mechanics tell you, then you're obliged to reach a conclusion that there are many, in fact, infinitely many worlds. So that's the whole topic of this paper that are going to be parallel worlds, if you will, to each other that have impossibilities to communicate with each other, but nonetheless, they all exist. And um, and basically that's what is discussed in this paper is um, the actual take from Everett initially, and that has been pursued by others like David Wallace, but also Sean Carroll, for example, to apply it in cosmology, has been to has been to basically follow again where the equations actually lead, and one of the reasons why people would want to do that and to use this Everettian interpretation is because this formulation of quantum mechanics does not use the collapse of the wave function postulate, which is in the, let's say, traditional or the taught at least quantum mechanics in universities. And so the goal is to do away with this postulate and simply again follow where the equations go. Um, Now, the what this paper tries to address is what do we mean by many worlds and what are these worlds? So what I want to express here is basically the dilemma that Wallace is trying to put forward. So let me here highlight the main problematic that it is trying to solve here. So looked at another way, defenders of an Everettian viewpoint face the dilemma. Just how seriously are we to take these worlds? So again, the formalism gives rise to worlds, but then how seriously should we take them? So what he says is that on the one hand, if we were to take them literally and build them into our formalism, then we would face the preferred basis problem. So the thing is that each time that's a problem that appears as well in decoherence. When you want to explain decoherence, there is a problem of so-called Ein selection. So why is it that the world, the classical world, is what it is, as if they were like preferred bases that were selected through decoherence, and there would be basically, if you imagine that the world you have in mind and you want to flesh it out in your formalism is kind of what it is and is kind of unique, etc., and its way of being described, then you're going to reach a problem about how do you choose the kind of mode of description of that world. So that's a problem. And that's what he says here is that decoherence would be no use to us, for we would need an exact world defining principle and not some pragmatic criteria. So the Everettian school relies a lot on decoherence. It's just that they don't reach the same final conclusion that many people in decoherence would actually follow, because it would, on top of it, they would add the collapse of the wave function postulate. Now, so there is a problem. Furthermore, there seems to be no relativistically covariant way to define the world. So that's an interesting thing, because we obviously people want also to have things that are, let's say, consistent with relativity. Then, if you can't, then this poses problem. But then he says, on the other hand, if we banish this world from our formalism, we must answer the criticism that our theory is just uninterpreted mathematics. And we need to be clear here. Although this may seem like a huge fantasy, David Wallace is actually really a realist at heart, and so he does try to put forward various arguments for the legitimacy, if you will, of the theory, of its formalism, and basically the metaphysics that comes out of it, and physics as well. So basically, that's kind of the idea. Now, one of the and that's where I'm going. So the article in itself, I think it's fairly readable. It's a philosophy article, first and foremost, so it's mostly it doesn't mean it's not technical at all. It's actually very technical, but there are always some examples that are helping us grasping on things if we don't have the level in mathematics to kind of get this kind of fully. But also, there is a very interesting point that is made about the philosophy of physics. And so one of the interesting claims here, that discusses about the role of theory in physics and in doing physics and science. So clearly, all scientists, and, well, I would say every scientist or every philosopher of science would have a tendency to have their own ideas on this, etc. Here, Wallace has his own ideas, but what I'm going to focus on here is a point he wants to make with regards to how the even talking about worlds in special relativity is already a huge problem. And that's actually one of the main focus of the paper. Something that is more philosophical, um, or yeah, that's more philosophical. But here, that's kind of the point I want to make. So what he says here is that he proposes a philosophical view of theories, and then he wants to try to understand what kind of world is being depicted in Minkowskian spacetime. So the simplest kind of relativistic spacetime we can think of, the one from special relativity. And what he says is that, well, one way we can conceive of a space-time is simply just by viewing it as a collection of basically places and instants, and basically a collection of events. And that's usually how it's conceived, to be honest. And where space and time are considered separate, and then we lump them together into a collection of events. That's what they say. As a matter of mathematics, we construct a four-dimensional space which consists of all points in space and at all times. And the space is a stack of all of the various spaces, each of which is space as we ordinarily understand it at a given time. So if you want to build space-time, you can imagine all these events, but one way you can build these events is naively imagining the entirety of space, and then at different time, and you stack these kind of layers. Now, one of the things that mentioned here is, and that's related to that particular word here, is that when you imagine space-time as space, as if it were a sort of absolute thing, and then you imagine stacking spaces basically in time, then that's what is called a foliation. And what the structure of Minkowskian spacetime shows is that actually you've got infinitely many foliations that can be chosen. And it's not like there is a unique way to so-called foliate spacetime into sequences of spaces along an increasing sequence of times. And so um, because there is already this kind of issues here, you may also reach problems related to instantaneity, and even the order of events may change depending on what you're looking at in a given foliation and so on. Okay, so the bottom line is that even in normal relativistic theory, you can't actually make sense of the word world. Um, because there are many ways to conceive of these worlds. There are infinitely many, so um, in fact, what they say is that in general relativity, it's worse. So you can have, and that the notion of simultaneity is completely artificial. So what they say is that you can have a multitude of space-like slices. So you start a foliation that are basically all kind of identical in our vicinity. So essentially, they would look like what we believe is kind of space or whatever, but then they are going to all differ from one another at greater distances. So essentially, these things are going to change with distance as well. So basically, the bottom line here is in special relativity, there are already plenty of problem, and and I just want to try to find the So that's what it says here. So, as a description of space-time, the many-instant interpretation leaves much to be desired. It contains arbitrariness, um, obscure structural features, the possibility to actually choose a foliation, and so on and so forth. And we ourselves cannot be said to exist in any single given instant as well. So that's more a philosophical take here, but that's part of the discussion as well. Um, and what he says is that nonetheless, it's a discussion, it's a description with merit. So that's the first kind of aspect. And what he says as a conclusion is that to say that space-time is an entity with such and such mathematical description, which are whatever we think of, which can be thought of as a collection. So that's the important part here, which can be thought of as a collection of all instantaneous spaces together with the metric relations between them. Fair enough, no matter that it may be decomposed into such a collection in many different ways. And so that's how actually space-time and therefore the world in special relativity can be described. And the bottom line here is basically to adopt the same strategy in quantum mechanics, but you replace the foliation of space-time into slices of space that are stacked at increasing times. You replace that by essentially different uh, basically basis to represent your world in quantum mechanics. Now, this is slightly more technical, so I'm not going to go into many details. As you can see, this is meant to be understandable by many people, so it's made it clear here, atom undecayed, counter untriggered, whatever, about Schrödinger cat, etc. So the paper is not super long, but it's still 25 pages, so I'm not going to go through kind of all of it. The whole point here is really to apply the principle that is used in special relativity for the arbitrariness with which worlds are going to be described, and apply that particular arbitrariness, or allow that particular arbitrariness to exist as well in quantum mechanics. Now, David Wallace has written plenty of other works on the many world interpretation, so if you want, I would really recommend that you look into his work. Now, if you want me to clarify some points, talk more about the many world interpretation, what is specific about it, by all means, do let me know in the comment section. And otherwise, see you in the next video.